Hello, hi, my name is Hassan Badru. Um, I'm supposed to. I created a video earlier for a counter from 0 to 9 using the Arduino board, using the Arduino microcontroller. But my instructor told me to make a better one, a better video, and a more illustrative video to explain to the rest of, to other students, or to people who don't know much about the way the microcontroller works. He told me to make it more illustrative, and I decided to, as I said, honor that request. Um, okay, the first thing I want to go over is the microcontroller. I'm going to go over the equipment I'm going to use to create the counter from 0 to 9. As you can see, it's counting already from 0 to 9. The equipment I'm going to use, I've put it down. I'm going to use a 7-segment display, the BCD decoder, which is the binary decoder, binary coded decimal decoder, the dual inline resistor, and the Arduino microcontroller. So basically, let me talk about the implementation I'll use. Most of us we worked on the counter before, but most of us did it while we were working on a digital logic class, and in that situation we didn't use a microcontroller. We used a flip-flop, and that was more that was a little bit different from what I'm going to be doing here. What I'm going to be doing here will be programming the microcontroller to count from 0 to 9 on the 7-segment display. Now back to the implementation. We all know how the BCD works, the BCD decoder from previous classes. We know that the BCD, which is the binary coded decimal, stores information in binary. So when you input a set of binary numbers, it's going to give you the result in decimal. So that's what I was able to implement, and this is what it is this is it's a 4-bit decoder. So on the first bit, the 0 bit, 1 bit, 2 bit, 3 bit. So if I input all 0, it's gonna give me a 0 decimal. If I input a 1 on the first bit, zeros on the other bit, it's gonna give me a 1, and on like that. Now back to the way I was able to connect it was that I connected the BCD to a dual inline resistor from this picture here, from the schematic, and then to the 7-segment display, to different pins on 7-segment display. And I also did a favor writing the pins that are connected to the pins from the decoder to the display. So pin 13 is connected to pin 1, pin 12 to pin 13, pin 11 to 10, 10 to 8, 9 to 7, 15 to 2, 14 to 11. I was able to derive this from the schematic, and I was able to, I just wrote everything down in an easier way so you can understand. And that's pretty much what I did for the implementation part. Now going to the coding. Let me review what the codes do, how the Arduino code works. The Arduino code basically contains 2 functions, the loop function and the setup function. The setup function runs the program only once, but the loop function runs the program continuously. So on the setup, the function definition, I declare all the pins. The setup definition, I declared all the pins as output: pin 1, pin 2, pin 3, and pin 13, pin 4, and pin 13. Pin 13 I'm going to be using for the supply voltage. And then I did something. I could have done it in a different way, but what I did in this situation, I outputted a high voltage, that's a high, on pin 13. So that means that pin 13 supplies the voltage for the voltage supply we need in the 7-segment display and in the decoder. Now, going to the loop part, the loop function. What the loop function does is it outputs the first pin, second pin, third pin, and fourth pin. Depending on which is high, which is low, it's going to it's pretty much the same thing as the table I drew here. When the first pin, second pin, third pin, and fourth pin is outputs low, it's gonna give you 0. When the first pin outputs 1, it's gonna give 1. When the second pin outputs 1 and the rest outputs low, it's going to give us 2. So basically, the high is the ones, the highs are the ones, and the lows are the zeros. Okay, now going back to the programming of the board, I use the Linux OS to program to run my Arduino compiler. Let me go to the actual code. Okay, now this is the code I used to count from 0 to 9, and the code contains there's a new instruction there which I didn't talk about, which is the delay. What the delay does is, after outputting a particular number, it waits for 1,000 milliseconds. So that's what happens. That's basically what happens. Now let me illustrate let me try make a different example of what I'm talking about. Right now, I just want to print out. I just want to output one number. Let's say I want to output 2, for instance, right? What I'm just going to do is okay, now it's counting. We can say it's counting. So basically, what I'm just going to do is type the code. I'm just going to do is I'll put the instruction here to print out 0, 1, to print out 0, 0, 1, 0. So that's basically what I did here. So the pin 1 is going to be low, pin 2 is going to be high, pin 3 is going to be low, and pin 4 is also going to be low. Now let me compile that program. Let me compile code. After I compile the code, and then I upload to the board, and after I upload to the board, we're going to notice that after I upload to the board, we're going to notice that after I upload the board, we're going to notice that the board is going to display just one number, 2. It's not going to count. Sometimes I have issues. I'm trying to connect the ports because of I'm having issues with what port it's connected to and what port it isn't connected to. So now let me connect it to the right port, serial port. Okay, now it's connected to serial port. Now I can verify. Now I can upload. My program to the Arduino board. And as you can see, what I said is just displays only one number at 2. It doesn't count anymore because I just put in one instruction. So now if I wanted to count just 2 and 0, all I'm going to do, I'm just going to put a delay. If I don't want it to have a delay, I don't have to put a delay there. I'll make all the outputs low, all the pins low. I'll make all the pins low. Let me compile, and I don't want to put a delay, so it's just going to go continuously. Now let me upload it to the board. It's just going to go. It's not going to wait. Just going to count. Let me see. Oh, I'll definitely need to put a delay. I apologize about that. my mistake. I need to put a delay of how many seconds I want. If I wanted to wait for 3 seconds, I put 3000 milliseconds. So in this situation, I put 3000 milliseconds. Now let me verify. And then let me upload to the bot. So in this situation, it's just going to show to let me reset. I'm sorry, I apologize. Yeah, so it's just going to show 2 and 0. You're going to wait for 3 seconds. So let me delay after the. I think I need to always put delay. This is something I'm running through. I'm troubleshooting right now. I just realized I can't. But the microcontroller is gonna get confused if you don't put a delay after each. And so now let me. It's gonna wait 3 seconds, then go to 0, then 2 again, 3 seconds. Go to 1 after 1 second, go to 0 after 1 second, change to 2 after 3 seconds, change to 0. So that's basically how it works. And I'm pretty much done with my explanation of the microcontroller, the Arduino microcontroller counter from 0 to 9. Thank you so much, and I wish you all a great one. That's